No code is perfect, and errors will occur. But don't worry, Python gives you tools to handle these errors gracefully. If you want to write robust, error-free code, then stick around because this video is packed with insights and practical tips that will make you a better Python developer. The try, except, and finally blocks allow you to handle errors and ensure that your program can recover from them. This is essential for writing robust code. Have you ever encountered a frustrating error in your code? Share your experience in the comments, and let's troubleshoot together. So, let's kick things off by talking about exception handling in Python. In programming, errors are inevitable. Whether it's a typo, a logical mistake, or something completely unexpected, errors will happen. The good news is Python provides us with powerful tools to handle these errors gracefully. An exception is an event that disrupts the normal flow of a program's execution. When an error occurs, Python generates an exception, which can be handled to prevent your program from crashing. Here's a simple example. We're trying to divide 10 by 0, which of course is mathematically undefined. Instead of letting the program crash, we use a try except block. The try block contains the code that might throw an exception, and the except block lets us handle the exception. In this case, we catch the zero division error and print an error message. But why handle exceptions in the first place? Well, without exception handling, your program would crash whenever it encounters an error, leading to a poor user experience. By catching exceptions, you can either fix the issue on the fly or provide useful feedback to the user, making your application more robust and user-friendly. Now, Python has several built-in exceptions that you should be familiar with. Let's take a look at some of the most common ones. Here, we have examples of value error, file not found error, and index error. Each of these exceptions handles a specific kind of error. When converting a string that doesn't represent a number, Python raises a value error. When trying to open a file that doesn't exist, it raises a file not found error. And when you try to access an index that's out of range, you get an index error. So, what are some best practices when it comes to handling exceptions? First, be as specific as possible. Catch only the exceptions you expect. This makes your code easier to debug and maintain. For example, catching a file not found error when working with files is more precise than catching a general exception. Notice how the first block is more explicit, while the second block is a catch-all. The problem with the second approach is that it might mask other issues, making debugging harder. Next, avoid silencing exceptions. It's tempting to just write except pass to get rid of an error, but doing so can lead to bigger issues down the line. Here, we're catching all exceptions but doing nothing about them. This might prevent a crash, but it also hides the problem, making your code difficult to debug later. Another good practice is using finally and else clauses with your try except blocks. The else block runs if no exception is raised, which is great for code that should only execute if everything goes smoothly. The finally block, on the other hand, runs no matter what, whether an exception occurred or not. This is perfect for cleanup activities like closing files or releasing resources. Now that we've covered how to handle exceptions, let's talk about raising them. Sometimes, you need to forcefully throw an exception in your code. In Python, you can raise an exception using the raise keyword. This is useful when you want to enforce certain conditions or indicate that something went wrong. In this example, we have a simple function that validates an age value. If the age is negative, we raise a value error. This forces the caller to handle the exception, ensuring that invalid data doesn't propagate through the program. All right, let's move on to debugging, an essential skill for any programmer. Debugging is the process of finding and fixing bugs or errors in your code. There are several debugging techniques you can use in Python. Let's go through a few of the most effective ones. First up is the classic method, using print statements. Print statements are a simple way to see what's happening in your code. By printing variables and intermediate results, you can trace the flow of execution and spot where things go wrong. However, while effective, this method can be tedious and messy, especially in larger code bases. For a more powerful approach, you can use Python's built-in debugger, PDB. This tool allows you to set breakpoints, step through your code, and inspect variables. In this example, setTrace sets a breakpoint in your code. When you run the program, It will pause execution at this line, and you can enter PDB commands to inspect variables, step through the code, and continue or quit the execution. This approach gives you much more control over the debugging process. If you're using an integrated development environment like PyCharm, VS Code, or Eclipse, you've got built-in debugging tools at your disposal. These tools offer graphical interfaces for setting breakpoints, stepping through code, and inspecting the state of your program. Here's how it looks in a typical IDE. You can set breakpoints by clicking on the line numbers, and use the toolbar to step into, over, or out of functions. The Variables panel lets you inspect the state of your program, and you can even modify variables on the fly. Another great technique is using Python's logging module. Unlike print statements, logging can be configured to include different levels of information, from debugging to critical errors, and can be easily turned on or off. In this example, we configure logging to show debug level messages. The advantage of logging is that it's more flexible and can be easily integrated into larger applications. You can log messages to a file, filter them by severity, and format them in various ways. Finally, let's talk about creating custom exceptions and debugging them. Sometimes, the built-in exceptions aren't enough to describe the errors in your application. In these cases, you can define your own exceptions. Here, we define a custom exception invalid age error. This allows us to raise and catch exceptions that are specific to our application, making the code more understandable and maintainable. Debugging custom exceptions follows the same principles we discussed earlier. You can use print statements, the PDB module, logging, or IDE debugging tools to trace and fix any issues. And that's it. We've covered a lot of ground today, from handling built-in exceptions to debugging your code like a pro. Remember, exception handling and debugging are essential skills that will save you countless hours and make your code more reliable. If you found this video helpful, don't forget to hit the like button and subscribe to the channel for more in-depth Python tutorials. If you have any questions or topics you'd like me to cover in future videos, drop a comment below. Thanks for watching, and I'll see you in the next one.